Okay, in this video I want to talk about how to solve a system of equations that's not linear. So all the ones we've looked at up until now have been just numbers times x plus numbers times y added up. Maybe there's also a z, but we never had anything like this where we have a square of a variable or anything more complicated, no square roots. So that's nice. But now we do. Okay, so let's see. We just want to keep our mind open and just think about the different methods that we had before. So don't get locked into memorizing what the steps were or what the circumstances were when we tried substitution versus elimination. Just look at a problem and see, does it look like substitution might be helpful? If so, try it. Does it look like elimination is possible? If so, try it. Okay, so looking at this first equation, or first system of equations, I don't see anything that's immediately going to get eliminated, or I guess actually elimination won't work at all because we have an x squared and an x. We're not going to be able to cancel those two out. They're not even like terms. So even if I tried to subtract things, they're not going to cancel out. Same thing with y's. We have a y and a y squared. On the other hand, we are kind of set up perfectly for substitution because we already have the second equation written as y equals something. So why don't I take this y equals something and plug it into the other equation? That's inherently what substitution is all about, is if you can solve for a variable, plug it into the other equation. So let's try it. So I'll take this y is 2x plus 5 and I'll plug it in for y in the other formula. So taking my equation x squared plus y squared is 10. I'm going to replace the y with 2x plus 5. Okay, so it looks like I'm going to have to multiply 2x plus 5 times 2x plus 5. So I'll have to use FOIL. So first term will be a 4x squared. Outside is 10x. Inside is also 10x. And last is 25. Oops. And next up, I want to combine like terms. And I might as well also, since it seems like it's going to be a quadratic, I'll move the 10 over to the other side, so I'll be able to combine the 10 and the 25. So if I subtract 10 from both sides, we end up with 15, 20x, and a 5x squared. Okay, notice something. We can use quadratic formula, we can use the AC method, but everything's a multiple of 5. We should factor out 5 first. So if I factor out 5 or divide both sides of the equation by 5, that's also okay. We end up with x squared plus 4x plus 3 inside the parentheses, which factors as x plus 3 times x plus 1. Okay, so if this product is 0, then one of the parts of the product has to be a 0. 5 can't be 0, so either this is 0 or this is 0, which gives me either x is negative 3 or x is negative 1. Okay, as far as I know, both of those are viable, so I need to check both of them and figure out what the corresponding y is. So my solution to a system of equations should be a point. What's the value for each variable? So let's see, I can either plug negative 3 to find y, I can plug negative 3 in here and solve this equation for y, or I can plug negative 3 in here and solve this equation for y. I feel like that's more annoying because I'm going to have to take a square root, and then I'll have plus or minus, and odds are there's only one solution, so I might need to check my answers. So I think I'm just going to use this bottom equation instead. So if x is minus 3, y is going to be 2 times minus 3 plus 5. Negative 6 plus 5 would be negative 1. If x is negative 1, then y is 2 times negative 1 plus 5. Negative 2 plus 5 would be a positive 3. So our two solutions, and we should go back and check, make sure they satisfy both the original equations. Either x is minus 3 and y is minus 1, or x is negative 1, y is positive 3. So we actually had two solutions for this problem. If you actually looked at the graph, the reason that we have two solutions is this is actually a circle and a straight line. And a circle and a straight line, it's perhaps not surprising that they might hit each other twice. The picture doesn't look quite like this, but it's a line and a circle, and so, yeah, it's possible to have two answers. Unlike our linear systems, if we're talking about two lines, either they have one answer, they have infinitely many answers if they're the same line, or there's no answers because it was two parallel lines. Okay, anyway, let's look at another example. I could try substitution again. It's not a bad idea. Solve for maybe y and plug it into the other equation. But it looks like somebody is setting this up specifically to make it easy to eliminate. So why don't I just try that? Because we already have a positive x squared and a negative x squared. If I just add the two equations right off the bat, the x squareds are going to cancel and we'll only have one variable left. 2y with no x's is equal to 6. So I only tried elimination because I happen to see that things will exactly cancel. Might as well divide both sides by 2 and we get a solution for y. Y is 3. And then once I know y, plug it into any of the previous equations to figure out what x is. It looks like the top one is probably the easiest of the equations that have an x in it. So I'll plug 3 into this top equation. 3 plus x squared is equal to 7. Subtract 3 from both sides to get x squared is equal to 4. And then take a square root of both sides to get x is equal to plus or minus 2. Okay, I'm not really confident in my answer because I don't know ahead of time what this picture looks like. It could be that there is indeed two solutions. There's x is 2, y is 3, but there's also x is minus 2, y is 3. So I think I should check my answers and make sure that they both work out because I don't want to find out that one of these was really an extraneous solution. So let's plug them in. So problem on the right, checking my answer. I wasn't as worried about the first one because we were plugging into a linear equation, and I feel like there's not a lot that could go wrong plugging into 2 times x plus 5. But here with x squareds, I'm a little worried about maybe information is lost with the pluses and minuses. So I'm going to check x is 2, y is 3 first. The first equation would be 3 plus 2 squared equals 7, which is true. 3 plus 4 is 7. Second equation would be 3 minus 2 squared is minus 1. 3 minus 4 is negative 1. That also works out. So x is 2, y is 3 would be a valid solution. Okay. If I plug in negative 2 and 3, then we would have 3 plus negative 2 squared, which still ends up being 7, and 3 minus negative 2 squared, which still ends up being negative 1. So I guess they both work out, and I was worried about nothing, but it's not a bad thing to check your answers just to make sure that they do actually solve the original system of equations.